Okay, so this means that we are designing these poles for axial load and out of plane and in plane shape. Okay? Have you started or have you finished this one? Or
Yeah.
not? I think so. Tushin?
Yes. Is it fine to submit my Excel? Right.
Yes?
I did everything in Excel.
Excel?
Yeah. With formulas and everything. Everything.
Okay, just to print it
Print it? Okay.
like PDF.
Good.
So everything is allowed for this because there is no rule, so I can. Because some of you are no rules are present. So, so some just manually doesn't know. If we suspect you, Tushin will come back to you and ask you who is the owner.
I'll do
of
it
this?
in breaks.
Exactly.
I'll
Yeah.
fine.
Okay, so
1 week for
for the reinforced masonry assignments. So the first requirement is design for axial loop. So design the load bearing masonry wall to resist the axial load shown and bending due to the pressure of 2 kPa. So what is the maximum axial load here? What is the maximum axial load Arco?
only 4.9.
94?
0.5 for the internal.
Yeah. So we have external and internal. The internal is more critical because it carries more load.
Yeah.
So what is the formula? And what is the
It's already factored.
Yeah.
Then you
So-
have the self weight.
So for axial load, we need to check that FD less than or equal to 5 KES FM prime AB plus
We do that?
KC FCG prime divided by 1.3 to the power 0.55 plus 0.005 FCG prime multiplied by A ground plus alpha R Fs yield A.
Yeah.
Okay, so this is the design load or the design force. So we need to know what is the applied load. Okay, and this is the capacity, as you know. All of that is the capacity. We have 3 terms in the capacity. What is the first term?
The brick.
Yeah, the masonry or the wall itself.
Mm-hmm.
What is the middle here?
Grout.
And
Steel.
the reinforcement or area steel. Steel reinforcement. Okay?
Yeah.
So the first step, I will not go through by numbers, but just to give you the steps. Okay? So, which one is critical?
The middle.
The middle. So we have 7 from the roof plus 22 from the third floor plus 22 from the second floor. What else?
Self weight.
Self weight. So how much is the self weight?
It would be, we have to calculate for the concrete and for the grout separately.
For the brick and for the grout.
Yeah, so for the brick itself, how much?
It will be the volume of the brick.
Yeah, 22
Yeah.
this kilonewton per cubic meter, right? Multiplied by what?
The volume.
By
What's the
the
volume?
thickness,
The volume? The volume except for what?
And
The volume and divided by 1 meter,
1 meter, yeah.
because we don't know the length.
Yeah.
So anyway, we don't have the length, so we can't find the volume.
So the cross section.
So the height times the thickness. What is the thickness?
190.
190. So 0.19. So this is the thickness.
Yeah.
right? Times what?
The height.
Height. How much the height?
10.5.
Yeah, 3.5 times 3. 3 stories. Each story is. Okay?
Yeah.
If you want the volume, so I need to multiply by L, then divide by L to get it as uniform load. Because all the loads are
Distributed.
distributed loads, so we need to distribute again.
Oh, but we need to remove the holes. We need to remove the holes.
Yeah, but this is the but we
All,
don't.
what hole?
We have the grout. The grout has a different density.
Yeah, we will add the ground. If you want to be more accurate, add the ground.
No,
Because
but
this is 200.
There's 22.
200.
You see, it is as one.
so you, but we don't remove the holes and then add the grout because.
Too complicated.
Oh.
If you want to stay forever here, we can do whatever.
That's what we did.
We can do whatever you want. But the idea is, what is 22 kilonewton per cubic meter? This including the hole. So is he considered the hole?
whole thing.
So he gives you the density for the
whole
block
thing,
and the
yeah,
mortar
block
together.
together.
Okay. Well, if you want to be more accurate, you need to add what? The ground. Okay. But actually, all of this is just to be like, why we add this one. This one will not affect the calculation, but we can't ignore the self weight. Okay. So at least we here consider the self weight. But if I omit this part, so this means that there is no self weight in our lab. But if you want to go more accurate, you can add the ground. Okay. How can we add the ground?
Yeah. Take the volume of the grout and put the volume of the grout. It is. We did.
Ignore. Okay.
We're not gonna do it again, but see.
Yeah. So this is the total loop. So this is the left hand side of the formula.
Okay.
Now we come to the right hand side.
Yeah.
Okay. Now what about the right hand side? What do you get in the right hand side?
Shouldn't you add the floor load and roof load onto that FD as well?
It's done.
We already have. We have 7, 22,
Okay.
22.
Yeah, that's it.
Yeah. So 44 plus 7, 49 plus this one.
Yeah.
So whatever 50, 55, whatever the value. Okay, so now the second part is the formula of the capacity.
Yeah.
Okay. If you try this, what is the problem? It doesn't give you anything, right? So you need to assume. So what you know only the masonry type
Yeah.
and the grout. So he gave you some information about that. How can we get FM prime? We have done this many times.
Yeah.
K, H,
Yeah.
FMB prime. You make it too warm. You play with the electricity, right?
Who?
You, right? So how much is the temperature now?
How is that?
How much is the temperature now? 28?
Come on.
I will ask you to continue replace me because make me like headache now.
Making me sleepy. It's making me sleepy. It is warm in now.
Oh,
It's from Europe, so this temperature is.
Now it's gonna be fine.
Yeah. How much it is now? The temperature.
24. Well, on
Before
25 or not?
before it was 25.
25. Yeah, but it was a mistake. It was Basir.
Okay. So we know FM prime equal to KH FMB. How can we get FMB? Can I say about 3.1? So the step is that it is not a problem with you. I will just proceed. Okay.
Yeah.
So for this part, it is okay. What is AB?
The area, the bedding area.
AB is the bedding area. What is the bedding area here?
The
2 times 30 times 1,000.
2 times 30 times 1000.
yeah.
Just to be careful, when we don't have the length of the wall, we working on 1 meter running.
Yep.
Okay. If we have the length, we can have both. Right. So this is 2 face shells. Okay. So area bending is okay. So this part is okay. So now for the grout, do you have any problem with the grout?
No.
The grout we know FCG as
25.
given, this one given. So no problem with the FCG. In the test or any other assignment, if it is not given, you need to assume it. Okay? Anything is not given to you, you should be able to assume it. Because otherwise, we will not be able to proceed. So, we have this one, we have this one. So, what is KC? KC?
1.4.
KC 1.4 for hollow concrete masonry greater than 200, 2000 kg per cubic meter or 1.2. So how much it is?
1.4.
1.2.
Oh, what?
Yeah, I'm pretty sure it's the last.
Is it 1.2?
You see? Yeah.
1.2. You take it 1.4?
I took 1.4.
No, because it's 2,200 kilograms per meter cube.
Yeah, I got 1.4.
The hollow.
Yeah, I got 1.4.
If you remember in the class, original
You
class,
showed us a different way where you
Yeah.
go to the AS 1100.
this is the problem between the
I didn't
teaching
worry.
style here or
I just took it as what they gave.
it will not affect what I mean, we should know how to.
If we write our justifications to why we chose 1.4, that should be fine, right?
What is the justification?
I saw it in
That-
class.
that-
ChatGPT told me.
No, because it's
Actually, it's greater. It's greater than the.
You know the standard that
It's greater.
Yeah.
The value back.
Okay, there is a small thing here, guys. Here, this is not the unit. 2,200 is not the
I
unit.
just did it all that way.
Yeah,
So this is not.
but it is not actually that.
That's
Okay.
not the actual.
Okay, if you remember in the class, the original class, when we maybe last week or something, the week before last week,
Yeah, you went to AS 1170.1.
in AS 1170.1, if you go to table A2, so this block, what is this block size? 290 times what? 190 times 190, right?
There you
So here the standard mentions the density of the units, not the density of the whole masonry. There is a difference between the masonry and the unit. Unit means the block itself without the mortar. But this value, 2,200, is for the masonry as a whole. Okay? That's why in the solved example we did before, it was.
Do we have to change that though? Can we just submit it?
You can we will not.
It's not going to.
Yeah, okay, it's okay. I mean, I just tried to give you
Yeah.
the correct.
It
Because
says
if you put the number 1.8, it will not affect the calculation will still go through. But I mean,
Which one is it?
okay, this 2.1 is kilonewton per watt.
meters
You,
square.
you need to divide
Kilopascal.
by the thickness
Yeah.
to get it as kilonewton per cubic meter. You will find it around 10 or 11. If you remember, we calculated as 11 kilonewton per cubic
Answer
meter.
will be less.
Yeah. So this block actually,
It is less.
the block density is less than 2,200 kilogram per cubic meter. So Kc should be 1.2, but it will not affect your. If you did it at 1.4, it's okay as well. So this should be 1.2. Now, what is area gross? Area grout, sorry.
It's 130.
So the second one is area grout. You know how can I find area grout?
Yeah,
Okay. How can I find area grout?
with the hole.
Get AD first.
So we have, this is the two holes. How much is the dimension of these holes? Is it given?
130 by 102.
130
Yeah.
by 102?
Yes.
Is that correct?
Yes.
So area grout, because we will fill this part with grout, right? So what is the area of this part? 2 times 130 times 1 also. So this is for one block. So we need to multiply by the number of blocks per meter. How many blocks per meter? We need to multiply by 1000 over 290. Okay? So the block width, the block length, sorry, is 290. So 1000 per 290 is the number of blocks in 1 meter. Okay? So this one, if you want to find it exactly, another option is you
I just do AD and then got AG minus AP. It's 130,000 square meters, millimeters squared, sorry. That's what the standard says. It's like an early force to relationship.
yeah. Another option is area gross, area ground equal to the width, the area of the block minus area building.
Yeah.
Okay, how much area building we got it here, but this means we just ignore that this part. Okay, yeah, it doesn't matter.
That part and then the side.
Yeah, and the side as well.
Yes.
So both options are okay.
Oh. Hey, I'm not wrong.
Well, the standard says you can do it that way.
Yeah. I mean, technically.
Okay, what is the next step? So you got area gross. Just because in the example we share with you for units A, it used this way to calculate it exactly. So he calculates the area of the holes and calculates the area using the holes. Okay? But the standard mentions that you can just take the whole width and then subtract the area bedding. So area ground will be all of that. So this is area ground. Okay? So what is the next step? So if we know KC and FCG and AG, we finalize this part. This part, we don't know the part, so we need to
Assume.
yeah. You can assume and check or calculate it by reverse. You know what I mean? You can reverse calculate the required area. So we know FD, right? And we know phi and KS and all of that. So we can find what AS. Or we assume 4 bars or whatever the bars and then check. I think it's better to reverse calculate. So what is alpha R first for the steel? What is alpha R? If you remember, alpha R is 0.4 for walls. So alpha R is 0.4 for walls. Have you used this one? Or we can it can be 0 or 1 or 0.4. So 1 for beams, 0.4 for walls, and 0 for concentration. What else? F yield. How much is F yield?
500.
500. This is the yield strength of steel. Right?
Yeah.
Okay. So now we can get the required AS. So how can I find AS? We have everything now. If your business is 0.4, 500.
You can
So-
assume the first one and then go seek afterwards.
You can assume M16s and then
This will make you at least do 2 trials, for example. If you don't want to do trials, so you can just, FD,
You have
equal to,
you know the minimum that you need because it has a clause for it.
Yeah.
0.002.
you can start with the minimum as well.
Yeah, that's what
There is
I,
a lot of options, but
yeah.
you don't-
Okay, if you know FD, you just put it that as an
Yeah,
unknown. And
if we have only one unknown in formula, so it's better to get the unknown and then increase. Okay? It depends on the experience. If you think the wall is too strong and the load is too small, so you can assume the minimum and the minimum will be enough.
yeah.
Okay? But anyway, it's up to you to assume or let's assume the minimum first. Let's do it like that. Okay?
It still works.
Because anyway we will check the minimum. What is the minimum enforcement?
10.
The bigger spaces.
What is the minimum?
Spaces like 290. No, probably like
AS should be more than
I'm going to change it now.
0.02 or 02
The I is input
AD.
AD would be
Yeah, so it'll still pass. It's still
Okay, correct. And what is the area minimum? This is the formula?
Yeah.
Okay. Have you calculated area minimum? So this is the, if you check this page, what is this page? 98. One of the requirements of the enforcement is to have a minimum area of 0.002 AD.
Yeah.
So anyway, you will check that, so it's better to start with this one, to see if we are far from the minimum or around or whatever. So, how much AD?
380.
380.
Oh, yeah, the whole, sorry, the whole answer. AD
Do you have a number?
190.
190 times
190 times
190,000.
times 290. We are calculating for 1 meter.
Oh,
It's 190,000.
Yeah. So we are calculating the area for 1 meter. Okay?
Yeah.
If you want to calculate for 1 block, you multiply, but it doesn't work like per block. We work per meter. Okay? Because our load is what? Per meter. So how much is this value? AS should be more than or equal to
380.
380 millimeter square per meter. So we need reinforcement with the area of this value or more than this value.
Yeah.
Okay. How many bars we could get? Let's say how many blocks per meter? Around 3.
Yeah.
If you look how many blocks? 3 at least.
Yeah.
3
And some.
bars. So you need to assume the number correctly. So for example, if we take 1 and 1, so how many per meter at least? 4. Okay, 4 will be a good number. So how many bars we need? 4 in what? Do you know how which table or how we did it?
I just assumed,
One
well, it's
steel.
113 divided by 1,000.
If we don't have the table, how to do it?
Okay, the area.
380 should be n times by diameter square divided by 4.
Yep.
So you assume the number as 4. So you can get the diameter. How much is the diameter?
It was 10.
Can you calculate?
Yeah.
Yeah, you get calculate.
I just adopted 10, 12.
It's okay. How much? 380 times divided by 5. Root. So we need at least 10.99. So this should be rounded up to. So we need at least 4 and 12. This is the minimum reinforcement needed for this part. Okay? So then we can go back and substitute in the formula. But what is the actual area? Area S is not now 380, it is more than 380. So you need to go to the table to find how much exactly 4 and 12, or you calculate it again. How much? So 4 times by 12 squared divided by 4. How much is this value? 452. So 452 millimeter square.
You change it?
Okay. Then,
You change it?
yeah.
The steel.
I just if you don't have the table and want to make it quickly, so
Stay on the N6.
the table is made by this.
Yeah.
The original.
Yeah.
So I did it like this.
Later on, they will know who is the winner.
I got the minimum,
Yeah.
It didn't work for that.
adopted N12, and I just adopted 290 space in center, symmetrical place. And then you get the total area, I divided by the spacing by a metre, how much per metre, and I got 390. Go to 380.
We use
It's the same thing.
Yeah. The design is not like one way, so just follow whatever you want. So now how many bars? 4? 452. So what you need to do now, Tushin, you need to calculate the value for this bar using AS equal to 452. Okay? Do you have a number? Anyone of you have a number? from your calculation?
For MD?
Yeah. For FD, if we use this part,
Yeah. With that part, no.
589,
kilonewton from
589.
We go 600.
So now FD, our design rules is what was around, let's say 55, and the capacity is how much? Let's say
500.
600
600.
Newton, 600 kilonewton per meter. So if we use 4 N12, the capacity 600 kilonewton per meter. So is it okay or not?
It is.
Okay. Okay. So the minimum reinforcement was enough because we can't go below that.
And this is compression. So
Yes. So the applied load 55, the capacity is 600, so it is okay. Okay?
Yeah.
Easy?
Yeah.
With what you got?
Slightly different.
Yeah, we don't need to be exactly the same, but because we have assumption. So the assumption I did is what I get the minimum, put it, and then calculate. Because we can't go below the minimum. Another option, if, for example, if this wall is too small and we need more reinforcement, so it will be high below the high above the minimum. So it depends on the case.
My FD for internal was 94.8.
What?
It's not 55, it's 94.8.
Oh, we have to add the self weight.
Yeah, I just put a random number.
Oh, okay.
And then, yeah, my capacity was about, for the internal,
Okay, guys, this is not numbers, random numbers.
was 800, basically, 799.
Okay? I'm not calculating, I didn't try this myself, okay? If I give you the solution, so I will not mark you as right?
What is your
Mr. Ali, he is in lead now. Okay, any problem with the first part? The problem actually is the second part, right? The moment.
The moment is the problem.
Yeah. So,
Where do you get the markers from, Ahmed?
my book. I have magician, so
Yeah,
I
they
have a
look
lot.
better than the regular one.
Ah, yeah. There is no regular one in the university.
Took all the markers.
They reduced the budget for markers.
Yeah. They put it in the MS.
Yeah, either
Do you
one.
have any classes there in City East? No?
No, we don't go there.
Oh, is the practical going to be in the city?
No.
Yeah, you go to the city and everyone else
Again?
will be in-
No, it's
No,
here.
it's mostly
Oh, it's mostly late. Okay, good.
Good, fine.
Oh,
in the building.
Car park is so expensive.
I had to park
In the bush. He parked in the park. On the tennis courts.
Before there was Horizon Park, but they closed it.
only staff have access to the park.
Yeah.
No,
No? No one has access.
no one.
To park for free, I wear a yellow vest.
And
So when I get out, nobody asks questions.
you need like use.
Oh, there is a formula for the eccentricity. The fact is C equals 3 times.
Okay, so what is the second question, guys? Or second part of the first question? We need to design for what? For out of plane building. Have anyone finalized this one?
Yeah.
Let me see. There is a.
So the bending out of plane bending would be on just the exterior of
Yeah. Because the window will not get a side.
Yes.
But for out of plane bending, it doesn't matter because
Yeah.
for the first part, because we have different axial load, So that's why we pick the critical one.
Yes.
But for the second one, the external wall will be subjected to what? To the pressure. So they ask us to design for a wind pressure of what? 2 kVA. Right? What is the enforcement we get from the first part? Just a assumption or just explanation of what we got.
N12.
N12 for N12 per meter.
Yeah.
So what does this mean? Cushion as center to center 250 around.
Yeah.
Yeah.
So this divided by 4.
Yeah. But
No,
200
I
is not.
think 300 works best though. I realised that later because you have to make the spacing fit into the block
Yeah.
because you got the 10 meter
Yeah.
joint as well.
If you gotta do that, then yeah, I gotta think about it.
Yeah, you got the ability.
Yeah.
So anyway, we have one.
So we can give it a range and like maybe.
So now, how much the max the distance between the bars? 390.
290.
290.
I
Sorry.
took 290.
Yeah.
Took 250. I think 300 works the best.
And you have calculated that we can do
because we go 6.
bars per meter.
We did the
right?
ratio.
Two.
What? This is the vertical one.
What did you guys say?
We go
We
6.
will check now.
Huh?
We will see now if we need or not.
We go 6. How many bars do we
Okay.
actually need
So this 4
Oh, okay.
and
after we got the load?
12 per meter. Or N12 at 290 millimeters. Just to fit with the holes of the block.
Like mathematically exactly.
Okay.
We did every.
Because if it is also the hole is not narrow hole, it's
Yeah.
big hole.
I got 3.4 bars
It's
per
100
meter.
or 130 meters. So you have room to move. Okay. Anyway, it will not be exactly in the middle, but it's okay. I mean, if it is 250 or 290 or 300, it's still fitting in the hole.
Mm.
Okay. So now, what we got? We have vertical reinforcement. Because this problem or this example has trick here. If we read what he asked us to do, he asked to design this wall. Does he give any information? No.
No.
If we look to the solution, the question, sorry. So design the wall for bending due to pressure of 2 kVA due to wind loading. Does he give anything? We only give us M3.
Yeah. We have the height, we don't have the length, so we can go per meter.
Yeah. So what to do? The first step is to check the formula. What is the formula for design? MD should be less than or equal to phi FS here A SD D times 1 minus 0.6 AS here AHD divided by 1.3 FM prime multiplied by BD. Okay? So this is our what?
The
Formula.
bending capacity.
Yeah. So we need to calculate the applied moment and check if the applied moment is less than or more than what the bending or the moment capacity. How can we do this or how can we calculate this?
The applied moment. Well, we can multiply the pressure by 1 meter.
Which one is the more critical mode of the three?
The top one.
The top one. Because of the connection
The
to
restraint
the
on top.
roof. Yeah, the restraint of the roof is the weakest one if you remember.
Yeah. It's
But anyway,
0.85.
you can, if you don't know, you can check. But we have tried this before, and we found that the connection at the roof will make the buckling or the slenderness of the top wall is the critical one.
Yeah.
Okay? So how can we start? Any advice or any suggestion?
Or which part? This or that?
Kinton?
So I just did
The apply moment.
Out here, I ended up getting those.
Yeah, we have discussed it. I just Jimmy, Mr. Jimmy and Judge, have you done this part?
Yeah. I sent them with the start date.
This is still about it.
Yeah, that's it.
How do you find the deflection on the reinforced slab?
Yeah, that's what we need to figure out.
Still in last year.
Is it good?
How can we find MED? So the problem is MED.
We have a pressure, we can multiply by the 1
Yeah,
meter.
we need to find
get
the
in
moment. So how can we find the moment? If this is our wall,
You can find moment per meter.
yeah, this is good point here. We don't know the wall length. So you need firstly to find the moment for 1 meter. So if we have 1 meter of the wall, this is the pressure. So if you remember, this now works as a slab. So
Yeah.
it's like a slab, and we need to calculate the moment of this slab.
Yeah.
So we need to know the support at the top and at the bottom, and if we have support from the side as well. So how many sides do we have? 4.
Yeah.
For any wall or any slab, we have 4.
I
So we
want
have
12 meters
top,
long. And not saying
side,
Uh-huh.
side.
it's so that all like
So
The only critical one would be the top one because it would have a partial restraint.
But
Rotation.
But because you have 3 sides,
we need to decide how many strain we have.
3,
3?
4, 3.
two-way bending.
Yeah. Based on the diagram given here, it should be two-way because he gave us what?
Because it's got the concrete floor, which is the strain, and then your walls on the other side, which are the 6 meter walls.
Samuel, have you finished this one?
Yeah.
You and Kenton and what's his name? James. James was good before he
Was
hit
good.
beside you. And now he's talking and what's your name?
Team.
No English name yet?
I got a nickname.
Nickname? What's your nickname?
Tony.
I think you are sad because of Real Madrid lost their stuff. That's why you are keep talking.
Real Madrid.
Okay, so what is the moment for this one, guys? You should have finalized this somewhere, right?
Yes.
What? What is 1.2? 1.2 kilometer per meter? Where do you get this from?
I disagree.
You picked the only mistake in the slide and put it in your. This mistake is I told you this is typo in this part. The masonry wall should have moment 1.2, the moment of the unreinforced masonry. It is not 1.2 kilometers per meter. If you go to the standard,
Is it? You just calculate.
yeah. So point C here, the moment MED should be more than 1.2 the bending capacity of unreinforced masonry. Because if it is less, this means it is useless to make it reinforced. But not this not the rule or the moment.
Oh, yeah, that's what I said. It has to be greater than 1.2. So
Okay.
I got 8.8. Sorry.
Okay. Whatever is the problem, we have a problem here. We have to decide what is the restraint for this wall. Because if it is top and bottom, so it will be simple supported wall, something like this. And the moment will be what? WL squared by 8. Yes, because it is simple. But if you assume there is restraint at the 2 sides, we should have two-way bending. Okay, and the two-way bending is hard to calculate the values of alpha and beta or beta y and beta x. Okay, so if we want to avoid going in this problem, what we should do?
Simply support.
Yeah, we will assume it is simply supported, and we will assume that it is only restrained at top and bottom. If you've done something different like direct, it's okay.
Yeah, I did the 2 ways.
Yeah. So if you want to do it two-way, the only thing I found online is that you can use the reinforced concrete. Remember the reinforced concrete slab? If it is supported by four supports, you can use the values of beta x and beta y to distribute the load. Because the load, if it is two-way, you can't mention that the whole load will go vertical and horizontal. That's not logic. The load is 100%, so percentage will go vertical, percentage will go horizontal.
Yeah.
But because there is no much information given to us, and one option as well, another thing is this wall. How much is the length of this wall?
12.
12. How much is the height?
10.5.
3.5.
10 point. Oh, yeah.
So we are working
Yeah.
for one story.
Yeah.
So if this 12 meter and this 3.5, so we should expect that most of the load will go also vertical. Okay? Why? Because 12 divided by 3.5, this is the aspect ratio, is more than 2. How much is this value?
3.4.
3.4. If it is more than 2, this means the wall is one way. Okay? So the length of the wall will make it one way. Okay?
Yeah.
So if this one was not 12, if it is 3 or 4, so we need to have alpha and beta, or beta x and beta y. But if it is like that, so the whole load will go vertical. So now can you find the moment? Can you calculate the moment for me? Yeah. What is the formula? How can we find the moment now? Anyone know? How can we find the moment?
Just W square by 8.
Yeah. So the moment MD will be, how much is W? 2. But this one is kilonewton per cubic meter. Right?
Yeah.
Multiplied by the 3.5 square divided by 8. But there is a problem here. This one is kPa, so we need to remember concentrated the load. This load is distributed over the whole area.
Yeah.
So you need to multiply by the width.
Yeah.
If you want to get it for the whole wall, so you need to multiply by
12.
If you want to get it by meter, you need to multiply by 1. So if we multiply by 1, so this moment will be something kilonewton
Meter per
meter per
meter.
meter. Okay? We don't need to calculate for the whole wall. Okay? We will just calculate for what? 1 meter. If I get 1 meter width, okay? So the load here will be 2 kVA multiplied by 1 meter.
We did 3.5 times.
Because this load, kVA means
which is 3.5
kilonewton per square meter.
is
So you need to multiply by the width of the load to make it kilonewton per meter. Then multiply by meter
because it's
square.
square.
So the final unit becomes kilonewton meter. Okay? So how much is this value? 3? 3.06? 06
It's wrong.
kilonewton meter per meter. Okay? This is the maximum moment of this wall. You understand how I got it? So what make it easy for us? The 12 meter. Or if it is not like that, we can assume it is only restrained at the top and the bottom only. Okay? But even it is not restrained at the top and the bottom, because the aspect ratio is more than 2, so it is one-way wall. One way in the vertical direction. Okay? So what is the next step after you got MD?
I'm sorry. Sorry.
Fixed.
So now, if we have one-way wall in the vertical direction, we don't need what? Horizontal reinforcement. Okay? The horizontal reinforcement in this case is not required. Or only for shear or other not required for what? For moment. Because all the moment come in this direction, so the reinforcement just in the vertical direction. Okay? How much reinforcement we have in the vertical direction? 4 and 12 per meter. So we need to check this reinforcement. So now after we got the moment, the second part is to calculate the capacity. What we have from the capacity equation and what we don't have.
We are missing ASD.
So for this part, we have 5.
Yeah.
What is FSCH 500?
Yeah.
What is 5?
0.75.
0.75 for all the reinforced masonry.
Yeah.
What is ASD?
AST.
Yeah. But we have to check, right?
Yeah.
What is the formula?
The minimum of
Yeah, the minimum of, or the lesser of 2.
Did we get it wrong? You fixed it?
0.29 times 1.3 Fm prime Vd divided by Fs yield and AST. How much AST? 452. Right? Do we have the values on the top? What is B and what is D?
I did mine per whole wall length, not per meter, so my value is
Oh, you can divide by
the same anyway.
yeah, so you can divide by 12. So we have 5 Fs yield, this one here. So this one 500, B and D. What is B and D? There is a formula, there is a
1000.
standard.
D is effective depth.
Yeah, B is the width of the masonry member. So B, in our case, 1000 millimeter.
Yeah.
So width
Oh, yeah.
of the wall. So if you are working on the whole wall, you take the whole length or the whole.
Yeah.
Yeah. If you are working on 1 meter, so you take 1 meter.
Yep.
Okay.
And DV took it as 95 mil, 190 divided by 2.
So what is the effective depth?
140.
Half of the thickness.
Effective depth of the reinforcement.
190. Oh yeah, 190.
By 2. Come on, you can't.
So as you know, the reinforcement in masonry in the middle, right? So how much is D?
95.
Yeah, 190 divided by 2, right? Or 95. So we have everything to find what, which one is lesser? ACT. I think ACT will be the lesser.
AST I got.
AST is less, yeah.
So this one is the smallest value.
Yeah.
So we will use this one as 452.
Yeah.
What is D again? 190 over 2.
Yeah.
What is ASY? ACD, not ASY. FSY, sorry.
FS1.
There is nothing ASY. So FSY 500, ASD same, 452. B and D same, so 1095.
95.
FM prime you know.
Yeah.
So can you check how much is MED we got? 3.06 kilonewton meter per meter. Less than, what is the capacity? 14.2. So the capacity is 14.2 kilonewton meter per meter. So safe or unsafe?
Say.
Safe. If not safe, we need what we do? Increase the increase the bar.
No, decrease in space.
No, because we didn't know.
Yeah, you have another two options. One option
So we
is
get
to
something right.
increase bar. So
We
instead
do
of putting
but
one,
together, no.
one yes, one no, or one hole and one no, you can put in each hole. Or increase the bar diameter. Or increase the wall
The size of the
thickness.
steel.
Yeah, the bar diameter is the size of steel.
Okay.
Or increase one, because we're already using the minimum only, right? So we can increase above the minimum. Another option, if all of that is, because we have also maximum reinforcement, is there any maximum reinforcement here?
Probably it's the whole of the ground.
Yeah, we can increase the wall thickness. One option, if it is excessive, for example, if this 20 and this 10, so we need to increase the break thickness. Instead of 190, we use the next one.
Finally.
Okay? Any question about in out of place?
No.
What else? What is the next part? B.
Shear.
Shear. in plane shear. Do you have a problem with the in plane shear?
Yes.
Which you want to design? The middle
The-
one?
Yeah.
The
Because
bigger
middle
one.
has
Critical.
600
The,
kilonewtons.
the largest.
Yeah. So do you have any problem with this one?
So it's not tipping over, or we have to check
You have to check what?
for tip over or
Check
not?
over.
No, because it's being restrained. So
Would you check? I wouldn't, but
Okay. So now design of walls for in plane shear. We need to first know what. We need to
Did you check?
decide what.
you, it is
So
already
check.
checked.
If it's long or
Yeah.
short wall or not.
The first step we need to decide, or we need to check if it is long or short.
Yeah,
So have you done this? Is
Yes.
it short or long walls?
it's long.
it's long. It's very long.
What L? 12.
Will you do that?
Well,
You know how much is it?
Oh,
You pay money for this. Like it's not for free.
but it's like
Because we have a thing in the office. If you find cards with numbers.
Okay. For in plane shear, what is the formula?
Eight. Why would you do that?
So here the design load or the design shear is given to us directly 600 kilonewtons. But before we design, we need to check if it is long wall or
Short.
short.
because it's long wall, you don't even need to do stability check. Is it right?
No, if it is long, we need to
Yeah.
check for stability.
Or really? Oh.
Okay.
what clause is that though? Because I can't find it. What clause is that one? Stability check?
Oh no, this is just from TV.
8.73.
Oh.
74, sorry. So, what is our formula to check it short or long? H over L. How much L? H over L? L, 3.1. So H is the height of the wall, 3.5. How much L? 12. How much is this value?
0.29.
Less than
With that,
2.3. So this one is a long wall. Okay? So long wall, so we have to check. Say 8.72 and 8.74.
yeah.
So for 8.72,
Did we do that?
our check is VD
Or we did only one
should be
check?
less than
Yeah, we didn't do that.
5
Do the second check, please.
F
I passed you an empty
VR
file, you know?
times A
Passed you an
D
empty Excel.
plus
I
0.8
made a mistake.
F S yield and
Actually, it's in.
AS. So we know FD already,
Yeah.
5.75. What else? FVR. What is FVR? 1.5 minus 0.5 H over L. So you know this value. Right?
Yeah.
What else? AD. What is AD? The design cross section area of the member, which is
1355.
yeah 190 times the whole wall length of the wall.
Ah, yeah.
Right?
12,000.
So 12,000.
Yeah.
Here we are not calculating per meter because it is not include per meter. So we need to calculate for the whole wall.
Yeah.
Right? Is that correct, Jim?
Oh,
So
Yeah.
I mean that you need to be flexible when we use 1 meter, when we use the whole length. Okay. So this AD, which is the cross section area of the wall.
Can you draw it so people understand?
Yeah.
Please.
So this 190, the width, and this is because the load is acting in this direction in plan. Right?
Yeah.
So this is our VD in plan. What is the next step?
The grout and the.
Yeah, we calculate already the first part. What is the first part, Arku? This is the contribution
That's the
of
masonry.
the masonry.
Ah, you
This
did
is
it on.
the contribution of
But
what?
here, you see, again, we're wrong.
What happened?
Because we split the grout and the thing.
But see, not to be too detailed.
And you see?
Just to be.
You don't have to split it. You just for the whole block.
No, bro, it's like it's safe anyways.
I understand because there's a large wall.
What do you even say?
I didn't say it.
Saying it all day.
He made me do the grout without the grout plus the grout.
The crowd make him confused.
Yeah.
No, it's
You see?
safer now.
Okay, guys. So here,
And
the
that's the-
standard didn't mention anything about it. They consider the whole machinery together with the ground by FBR.
Okay. So well, the steel we just calculate how many steel we can fit.
Yeah. So now for steel, do we have steel?
Yeah.
We have only vertical steel. Do we need horizontal steel or not?
No, we don't need it. And this is for the horizontal steel. AS.
No.
No, it's the vertical.
AS is the cross section area. We have only area steel vertical now, right?
Yeah.
How much? 4 N 12 per meter. If you look here, so they mentioned that AS, two cases. FH over L more than 1 or less than 1. It is less than 1, right?
Yeah.
If it is less than 1, so area is the total cross section area of the steel
With if.
of vertical steel or horizontal steel. Do we have horizontal steel yet?
No.
Not yet.
Salute.
Okay. So how much area is in this formula?
Zero.
452.
Ah, 452, yeah.
Here
It's the
took here
vertical.
is the total cross section area of vertical or horizontal?
Okay.
Which
no,
one?
No,
which-
but wait.
whichever is
452,
less.
452 is per meter. Here we have
Yeah.
12 meters, so
Yeah.
it will be 12
So
times.
what we should do here, we should multiply AS should be 452 multiplied by
12.
12 because this millimeter per meter. So how much? How much total?
For almost 5,000.
Yeah, almost six, like 500. 5424. Thank you, Rohit. So this actually is the total reinforcement area in this 12 meter.
Yeah.
Okay. So now we can check how much VD. 600. How much is the capacity? Anybody has calculated these two ones? Have you calculated?
Go to Shin.
Give me a second.
Yeah, just VFVR. Just to give a number.
FBR?
Nobody knows.
1.35 per FBR.
And he's all on record. For
Nobody will watch it the recording.
I did. I won the recording.
You watch it?
Yes. It's useless.
I put it while I go to sleep.
I think the standard.
I use it
is
as a
4.52
sleep
pixels.
podcast.
Yeah. he's talking about me recorded here, not live. Yeah. Because he privately recorded.
Yeah. That's
Yeah.
That's for
Yeah, I'm
Angelo.
talking about I'm saying jokes inside the recording.
Yeah, I have to go through all the editing. and
Make it
stuff.
eat.
Make it facial,
So what is the number? So this is the capacity. The capacity will be around 2, 4, 550 kilonewtons. So is this okay or not? So the word is okay.
Yeah.
Oh,
Man. You can bulldoze.
Okay. So for this check, this is the strength check. The wall is okay. Okay.
Yeah.
So our last check is what? 754. 874.
But sorry, there is one more to do.
Yeah, that's good.
What is 874, guys?
Stability. Service stability.
Stability check. So for close 8.74, stability check. We have to check that. What is the new number?
Checking.
So we need to confirm that VB less than or equal to 5 KSW BV L divided by 2 plus F S yield ASV L minus strength 2 L all divided by F. Okay? Are you okay, Basir?
Sorry?
Are you okay?
Yes. Some long equation.
So what we know that B sorry 600 again 575. So what is the other parameter, guys?
PV.
PV is the applied uniform load.
Yes.
So how much PV?
It would be 600 divided by 3.5.
No, the applied vertical.
Oh, vertical.
I did
Okay, that would be definitely.
FD. The vertical load.
Yeah.
Yeah, FD.
So what is the vertical load? Was the first load we calculated earlier, FD.
Yeah.
How much it was?
89. No, this is different.
So it's 22 plus 7 plus the same point. Right?
90 something.
90? How is it 90?
A random number.
6. We put it at 55 before.
Yeah.
Okay? So anyway, what is BP?
This
Vertical uniform distributed load on the wall.
specifies a random number.
Yeah.
Random.
Okay?
Yeah.
You need to get
And we talking about this 3.5 height.
No, 10.5 meter. It's the whole line. It's strength of the whole wall.
But in the
Is it times 4?
is it like cheap
times
like
12? Times 12? Why?
What is she?
Yeah,
no, it's saying.
You mentioned the standard mentions the applied uniform vertical load. In the calculation we did multiply or not? In the previous example. No, I know. In the previous example the week before last week. Do you have it with you? The unit number?
Last week.
The week before last week. Last week was
Amen. We have a fair point from Kenton. Kenton, explain.
If he is kingly, I will listen to him. If Kenton, okay.
I mean in the previous When we check in playing sheet, we only consider 3.5 meters.
Where? I didn't include any.
There for the height, if it was a long wall, we just use 3.5 meter
Yeah.
for the height when the building is actually 10.5 meter. Is that correct or incorrect?
It is not one wall. If you have, we
You have multiple walls separated by slabs.
Yeah.
That's
It's
the
not
answer.
one wall.
It's not one wall. That's the reason why. It's not
Otherwise, so if you have like multi-story buildings, so one wall is the whole building, it's not correct. So each wall is supported by the slab, and then the slab or the beam transfer into the cut.
But
I still took it as
should we
10.5
check
as well.
We did.
Yeah, but the solution's still roughly the same.
Yeah, but it is not case by part. Go. Where I didn't use the 10.5.
the 55.
Yeah, it's a random number. It's not a real.
The 55.
Yeah,
You
that's
mean,
a random.
you mean why I included in self-weight? This is what you mean?
Yeah,
Yeah, because which one is the critical wall of the three for the vertical load? The bottom one. Which one is more critical for the shear? The bottom one. For the out of plane bending, the top one because of the condition of the support.
Yeah.
Okay. Okay, guys. So if you have a beam, simple beam. Okay.
Yeah.
So actually, the span is one only between the supports, right? Here as well, if you have wall, so we have some support. So this is not one wall. We have segments of the wall. So we have like 3 segments of the wall. Okay. And the vertical load, because the load accumulating, so which one is more critical? The bottom one. Because of the shear also accumulating, which one is more critical? The bottom one. Only on the out of plane bending. Why out of plane bending the top one is the most critical? Because all of them under the same load. But the condition here are different. Right? The condition of the support. Which one is more critical in the condition? The top one, because of the roof. Okay? So that's why he gave you multi-story. Because you need to pick which one is critical in which case. Okay? But we cannot consider it the whole wall as 10.5 feet. Okay, Arkham group?
That's my. No.
Because you support Kingley at the start, I'm blocking the. Because you. So you understand the point now?
I did. I try to be supportive to my classmates.
Okay. Are you okay now, Kenton? Thank you. So now we go back to our calculation. The design is just to take the most critical case. So we are trying to find the most critical case for each design. Correct. Okay, what is the next step, guys? After we know PV. PV now we need to decide if it is uniform load or distributed load. Can you read the definition? Do you have the standard with you? Yes? No? Samuel?
I didn't bring it.
What's this?
Yeah, can you read the definition of PV for me?
The applied uniform vertical.
Okay. So he mentioned what? Uniform. So it should be uniform. Okay, Ravi? We'll try both. So just to go refer back to the example, but the definition mentioned it is uniform load. Okay. So what is the next parameter? So we know BV. What is L and what is KSW? Matthew, what is KSW?
KSW is.
A reduction factor used in assessing the design of overturning capacity of the wall. So there is a reduction factor for the overturning. So how much is KSW? 1 minus BV divided by AD times FM prime. So do we have all these parameters? Yes?
Yep.
We have BV, AD. How much is this factor? Should be less than 1. How much is the factor? 1.6? Give a guess.
Yes.
Have you calculated 0.7? Okay. 3. 0.723. Good guess, son. Thank you. Have you anyone calculate this one?
The same.
Not you?
Which one?
KSW.
One.
Yeah.
1?
Yeah.
Can't be 1.
I got 0.947.
Yeah, I mean I got 0.9999.
Yeah.
Yeah. 0.99. But like ours is different.
Oh, because the PV is wrong. Never mind.
Yeah.
So the PV has to be
Oh.
kilonewtons per meter. It can't be in a point load.
If it's 0.2, this will be too big.
Oh, 80. What is 80 for the whole wall? Or for just the,
For 1 meter.
for one wall?
So I've done it for the whole.
Okay guys, so if this be for kilonewton per meter. So this should be also area per meter. Okay. So this factor
Lloyd's
like
example.
0.9, yeah, 0.9 something is okay.
0.94.
Okay. 0.92 or 0.91, whatever. This similar value to what we get in the previous example.
Yeah, I got 0.94.
That's all. But not 0.5 or not 1. It can't be 1 because the reduction factor.
It's
Otherwise-
1 minus.
Yeah. So now what is the next parameter?
So the PV is 90.5
L.
OE multiplied
What is
by
L?
I did 94.8.
What is
times
L?
12. That's
The
what I
whole length, which is how much?
12. 1
12?
or 1 meter.
12.
I don't know what it is.
Okay, just a reminder of the
yeah, point.
overturning.
Yeah, it is point.
So we have V and we have what? CV.
Yeah.
So actually we are worried about what overturning of this wall around this point, right? So V will be multiplied by the height h
Yeah.
and BV will be multiplied by
Half of the length.
half of the length.
Yeah.
Okay.
I took PB as a point loader from
Yeah,
examples, but I still got 0.94 anyway, which is
Yeah, okay. Sorry guys.
because I did it for 12 meters. I did a little bit too
Because
much
this
anyway.
definition here is a little bit weird. So he asked, so applied uniform vertical loop. So here, it should be uniform loop because we are getting the area as per meter.
Yeah.
But here,
It's
because,
point load.
because we need to get it as concentrated to get the moment.
Yeah.
So in the top one, BV should be whatever the loop multiplied by what? So I write to read. Okay.
If we were to use, for calculating KSW, if we were used to use the 12-meter wall,
Yeah, you need to get AD for the 12 meter of
Yeah.
one. Okay. So again, what is BV for this part here for this calculation? It is 55 kilonewton per meter multiplied by 12. Okay. Because we need to get the moment at the resisting moment. So the black is the resisting moment, and the blue is what? Overturning moment. Okay. So by understanding the parameters, this should be concentrated loop. So this value is 55 times 12. This value is how much? The length? 12. How much F is? 500. What is the HCB? What is the HCB? The bar? The cross-section area of the shear reinforcement under consideration perpendicular to the direction of the applied shear and anchored. So this is the
Vertical
vertical reinforcement
The vertical.
because it is the perpendicular to the shear.
Yeah.
What is perpendicular to horizontal shear?
90 degrees.
The vertical force. Okay. So what is the HCB?
Will it be for 12 meters?
What?
Will it be for
Yeah, for the 12 meters.
5, 4 to 4.
Yeah, 5,
4 to 4.
4 to 4 is the total area. What is L1? What is L dash or L prime? L prime is the distance from the centroid of the reinforcement under consideration to the tensile of the belt. So where is the if we have bars like that vertically? So where is the centroid of this bar? Where is the centroid?
In the middle.
In the middle. Okay. So how much is the distance? L over
6.
2. 6. So this means
12 minus.
this will be 0. If you remember last in the example, we mentioned when if the CG of the steel in the middle, this means it is not contributing to this form.
Yeah.
Okay. You remember that?
Yeah. Because this reinforcement is symmetrical, otherwise
If it is not symmetrical,
it will work.
it will work. Anyway, where is the centroid of the steel? In the middle. If we apply in the formula, so this means this term is useless. This means the steel is not adding any resisting moment. Okay, guys? So, do you understand what this formula is?
Yeah.
The formula is the overturning moment should be less than the existing moment.
Yeah.
So the steel, actually, if the centroid is in the middle, this means it doesn't add any resisting moment to the calculation.
Yeah.
Okay? So this means this bar will be 0. So have you calculated what is h? What is h? Height. How much is the height?
You've got to choose how many you want to hang it.
3.5.
Yeah.
Okay.
So you want
Have you taken it as 10.5? It is not 10.5. It is.
3.5.
This is a question to you. Can it be 10.5 here? Do you think that we have force can rotate everything even with the slabs and the columns and so on?
No, you will string the wall again from the slab.
So it cannot be considered as one wall.
Question, why was it 0? I missed that part.
Yeah, where is the formula again?
Yeah, because I assumed, like, we anchored, I just said we'll anchor the first 4, because I think one of the examples you can assume how many you want to anchor, because you don't anchor every reinforcement. So then you can get the centroid from, like, the first 4, or if you choose 5, because it has to be anchored. So, yeah, mine's different to that.
Yeah, but you need more assumptions.
Well, I did. Yeah,
Yeah.
simple anchor
If
first 4.
you assume no anchor, so it's still 0 as well. So it
But-
depends on.
No, forget about it.
Because yeah, I did the first 4 N12s were going to be anchored, so the centroid was,
Consider the
you get L
side
prime
of
as
the
635,
wall.
and it's 290 spacing.
Yeah, but this
Yeah.
one,
For the ground.
Yeah, till the ground.
this will change AACB, not changing L dash. L dash.
Yeah.
So L dash is the distance from the centroid of the reinforcement under consideration to. Yeah, so if you consider ACB only,
But
yeah,
it's,
you're
under,
right.
it's under what's going to be anchored.
Yeah.
It's not from all your reinforcement.
Yeah.
You have to read above it. You don't anchor it.
All of them.
You don't have to.
Yeah, but you didn't mention anything in the assignment, so. Anyway, guys, so for this part, I will leave it for you. But let's say first, how much is this value? How much is this value without the anchoring part, without the steel part? Is this safe or not?
Safe. A lot.
A lot. So
A lot.
because the weight of the wall is enough to resist that. So if this part is okay, so we don't need to worry about the second part. When you need to worry about the second part, if it is unsafe. If the first part is unsafe, so you need to worry about the second part. Okay? But because we don't have enough information about the reinforcement given in the example, so we don't need to go too much deep. Okay?
Yeah.
How much is this value for the first part, guys?
6,000.
So 6,000. So this 10 times the values we need. So VD equal to 600 kilonewton less than the capacity, which is 60,000 kilonewton. This after you divide by 3.5 or not?
Did you? Was it?
I haven't done.
Any calculator with you? how much KCW? 0.9?
One adjustment.
Should be more than.
I use 10.5.
Oh. I'm getting 6. Yeah.
Wait, why did you times PV by 12?
Yeah. Yeah, that's when you see the episode. Yeah. Yeah, I did move that and that. Yeah.
How you calculate it at 6,000?
Sorry?
How you get 6,000?
It's not 60,000.
How much you got? How much you got?
I get 634.
So this BB?
Why you go 14%? Let's go. 90 something. Is the way of the wall. PV is the wall. Self-weight plus 22 plus 22 plus 7.
Okay, so it will be around, not 6,000.
You get all the slabs, all the self-weight.
It's about 14.
But you're
100
the
km.
whole building.
How was it? KSW is not 0.92. PV is, how much is PV?
1138.
BB 55, for example. This is just an example.
Yeah, and then L is 12.
Is
L is 12.
12 times 55 times 1.
12 by 2. 12 by 2.
Sorry?
Well, it depends how you do AD. If you get AD for the whole wall, you can do PV as a point load, but you can do it per meter if you do differently.
So it would be, PV would be like 50 times 6 times 1.
But here you have the
Why BB times 6? Why?
L over 2.
You mean here?
Yes.
Yeah, here.
Like if
So it would be PV times 6.
this
So PV is 50. 50 times 6 is
Divide by 3.5.
Okay.
Yeah, I calculated here, it is,
Does it read?
it will be 13.88. But, I mean, if it is not, if this part is not safe, so you need to move,
Isn't 50 times 6 300?
but it is not 50, it is not 50.
How much is
You calculate it and tell me.
Because with this, I mean,
And you need to multiply by 12 as well.
But,
Again, this 55 times 12, this concentrated load.
no, but PV is uniform.
Yeah, but you have to go to point load.
In this formula, I needed to make it point load. In this formula, I use it as uniform load.
So we times by L twice.
Yeah.
Yeah.
no, but in that one, in that KSW formula, you can use it as point load though if you use AD.
Yeah,
12 meters times 190.
Yeah.
You can do it as point instead of per meter.
If you have AD for the whole wall, so you need BB for the whole wall. If you have this per meter, you need this per meter. But here, you need it for the whole wall.
Yeah, which is what.
Because
Which is if you do KSW as the areas on the wall, your PV is going to be in that same form anyway.
Yeah.
That's what I saw already from.
yeah, it's no problem.
But this one
Because
here,
from this diagram, BB is the BB times L2 is the resistance model.
this one here,
No, this is
I mean, with the H being 3.5 instead of 10.5.
It's not like the same thing.
You can't necessarily say that because on the plan here you got
Because
shear.
this already makes it
600.
into number.
That's
L
fine.
here makes this
So you
into
can't say it's only acting on one.
It's not a moment.
It's basically acting on
It's not a moment, it's a force. Yeah.
No, there's not
That's
acting.
it. It is.
So if you
Tell
that's plan though, so if you flip it, it's essentially acting over the whole 2.5.
BD is a shear
That's what
force.
we-
It's not a
Yeah, in this
moment.
equation
So you
doesn't
should
work like
multiply,
this, or
like
when.
the L divided by 2 makes it already.
What if I use this as an L?
Point. So the goal,
I still got this on.
Yes.
2 centimeters.
PV is distributed because according to stat, do you understand that?
Oh, so you
Anybody?
can get rid of that man and that becomes
But this, if you, well, how you calculate that?
Right.
Yeah, I give 2
That's the
centimeters.
reduction factor, so it's
2 centimeters. And you have the number.
See, you are still
According to
to
4,
meters.
it's better than
Sorry?
4 bars. Is it 4 bars?
So,
How many Anyway,
Yeah, but this depends on how many you anchor. If you anchor all, so the centroid will be in the middle.
yeah,
I think.
I just said 4.
Yeah. So depending on how many, like for example, you anchor one and leave one, so you need to calculate like the area, like the centroid of the area. But we don't need to do this here. That's what I mean.
We've already done it.
Yeah.
So for this one you said no anchoring.
Yeah, if you can say no anchoring or anchor all, so it will be easier. But if you want to contribute this value, but it's already double. So if it is unsafe, you need to consider anchoring.
My
I see it.
my
It says
capacity
uniform.
is
Doesn't say uniformly distributed.
I did the 10.5.
Then in that case,
So
I think everything else
yes,
is great, it's really
because
That's
this is
the allocation of that.
and this is meters and they cancel out and they keep it as kilonewton. Otherwise they use because on this side you have area times pressure.
Where?
Even if you was pressure and area, when it's this is meter. So it keeps kilonewton.
Yeah, but because the slab, you can't consider that the whole building will rotate because of this
here
wall.
TV
This
is
not.
uniform, but here
What?
is
Yeah, because it's over 10 space. If you consider the whole wall, it means the whole building rotating about 1 point. It is not stability of the wall, stability of the whole building.
Yeah, this in order to.
Because you have a slab in the middle. Right?
This is megatons.
But we have this example in two previous locations.
I see. Even in the here.
Do you have any question for this example?
It must be because otherwise the units don't work.
Yeah, because you sweat.
Otherwise it's one. Also the other equation is not it must be point. So when
but it's a point.
yeah, because you are underneath you have area times pressure. Pressure is Pascal.
Oh, yesterday you were
square. You need to square times the area.
Yesterday
You have
it's
Newton. Otherwise you don't have five.
Yeah.
Okay. So
No,
this
I was
is
busy.
yeah, it must be a point. Because otherwise you will have Newton. As KSW, it cannot be iteration.
But here, also in the other one, it must be Newton. Because otherwise you don't see.
Sorry, Ahmed.
You see,
Go ahead.
Ahmed. Angelo is saying the PV has to be a point of area and gives you Newton. If you don't have Newton, just then KSW is.
We already used it as a point of two.
It's not a ratio. It is a
Yeah,
point.
that's one I've done.
Okay.
But it can be Newton per meter if you're
Yeah, so you can take the meter.
It could be a ratio.
Your point was fine.
No, because like
Okay, guys, again for the
times
baby,
by 1,000, like how you always KSW.
we have two locations for PV and the calculation here, okay?
Yeah.
PV here, because we calculate EV as per meter, so it should be per meter.
It should be per meter.
Here per meter, because we have
Only if you
EV
take
as per
AD
meter.
as per meter. If you take it as the whole wall, do it as a point load.
You know the walls at 12 meters.
Okay, so PV here, per meter, because 80 here is per meter. Okay, here PV is the moment. So how to get the moment, resisting moment? You need to concentrate this load. So how to concentrate this load? You need to multiply by the length. Okay. So here PV is 55 times 12. Here 55 only. Okay. You understand now this one?
If the area
Any
AD
margin
is
on
per
it?
meter, then yes. If the
In
area
my
you
original
got the
copy.
whole area, then
In my original copy, I
No,
already
it's
said
okay.
I didn't have that bit. Or
you need PV as point rule if you use the area as the whole area. If you put the area per meter, then it must be per meter. One area. Exactly. You have to simplify.
If you want to,
So you have to get rid of.
Do you remember or?
Yeah, yeah.
Okay.
If you have the distributed load PV, then the area is per meter.
Okay, guys, do you have any
The whole
question
area,
about
then
this
PV
assignment?
must be point.
One question.
What's be done?
Is this it? We find this one is that it?
Yeah. This is the whole assignment.
I'll upload next time.
So this is the whole assessment 1.2.
Do we wait for Irfan for timber or we move on?
What?
We wait for Irfan or not?
We still, do you have any problem with the practical? Practical?
Oh,
We still have one,
when is it due?
we still have one more class.
Next Friday.
Next Friday.
Oh,
The practical?
Yeah, just
Yeah.
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 This Friday is the assignment, right?
Yeah.
You got your group with who? Call Basiri.
One quick question. The timber, is it the same as cement timber?
So you're going through the practical stuff today?
Practical.
Yeah, you
Personally.
Yeah, yeah.
If you need help, just let me know. I can't go through everything. Just let me know. If you have any problem.
I don't know, in your email you said you were going to go through it, so that's the main reason I was here. I'm finished this email.
I just try to find the example you mentioned and take the whole thing. Actually, this week we should start at the timber. So the timber is the main topic. Is it first week?
So was your, so ignore that, was it 65?
Okay, here we want the examples.
94 from previously, because that was a 94 from par.
Have you seen this example before? It's same to what we have today, but two stories. So this one was, where is the answer?
Roughly what he's getting.
Because he just mentioned he takes the whole height. So.
Not 12 years. And then this is an extra thing that you don't have to do. So that's anchor notes for the.
Okay, so can you see here?
Just simply
Okay, correct. See here? What is H? 300. So the height of the wall is only for one story. You can't consider the whole building as one whole, as one wall. That is for everything. So.
I mean, that's the actual thing.
We have the example here. Nowhere else. Okay, maybe quickly we go through the practical. Have you seen the results?
You gonna stay?
Basir?
Yeah, I had a bit of a quick look. I haven't done too much yet for it.
You gonna stay? For the FTC?
Yeah.
Okay, I leave it there.
So for this part,
Yeah,
for this part, the material part,
Yeah. You just keep recording and follow whatever it is. It's time for me.
14 was just for one level.
this Excel file has all the data. Have you tried to like process any data or something like this?
Do we have to?
Haven't processed it yet.
We have to process each set of data.
You have to graph it, don't you?
It looks stupid on the graph.
Yeah, because you have to clean it.
Clean it from what? Get rid of the negative value?
No, when it goes like up and down, you have to keep it in one direction. So you get like.
Okay, so this is the root.
If you drop it into Copilot, he can do it. He can clean it for you.
So this is the root.
It says you're not allowed to.
So what is the maximum root? It's easy to, I will show you,
data.
I will show you an example and you can do it yourself, okay?
Yay.
So this one root, but we need to draw the relation or draw the relation between the displacement and the root. Okay? So how many information he give you here? So we have laser 1 and laser 2, laser 3, sorry. So we need to get the average of these two first.
Feeling?
Huh?
Feeling?
Yeah.
Can I have a copy later?
Yeah. Everything is on my YouTube channel.
Have a YouTube channel?
No, but I'm thinking about it. I could monetize.
Yeah, do it.
I could monetize. I will get like 25 views.
Okay, so if we draw this relation,
Ahmed has YouTube.
Eh?
Ahmed has YouTube.
Ahmed, you got a YouTube channel?
Yeah, he's a millionaire. I follow him on YouTube.
no time to do more.
Professional YouTuber.
About what? Like gardening? Cooking? What kind? Styling?
I hope I have anything like so I will be million views. I will quit.
You get more of a review.
If I found anything I can be watchable on YouTube, I will quit teaching. Okay, so have you tried this before? So this is a deformation.
Yeah.
Versus the okay, but the deformation is negative, so what you need to do, make it positive, so it looks better. So we need to
You can also make it. Yes, the outside. That's my name.
because we need to compare all of them in the same graph later.
Just we consider both. So for the case that if you have the you don't have.
Okay, so this is the load displacement graph for the first one. What is the maximum load? About 2.4. Okay. So you need to do something. So if you have two lasers, they give you two lasers because we have measured the two sides of the wall from the back. So to get the one displacement, you need to take the average. Okay. So the first step you take the average. Then if it is negative, you need to convert it to positive to make it to the right side. Then you select the two columns and then plot the graph.
Oh, so if it's negative values for on the graph, just swap them.
Yeah, just make all of them positive.
Okay.
Because it's just how the LVDT is measuring. So if you if it is pushing like for example this, if it is pushed like this, so it's positive. If it is like this, so it's negative. So
Because you say on that up the top there in the column, you got negative 1.05. Can we just make them all positive?
yeah, I can
Is that
remove all
what
of
you're
that.
saying?
So some of the data are already wrong.
So we can just make it all positive. I take the absolute.
If you want, you can just delete all of them.
All the negatives.
Oh, all the negatives. Okay.
Okay, and then put 0 and 0 at the start. That's it. Okay, so
Still got some negatives.
No, that's just made those into positive.
Oh,
Okay, so he's using that.
you just took the absolute.
You just did negative of all. Yeah, cancel the negative. I mean, you can do absolute. But the small values they won't affect it.
okay. The first part of the test is just the jack and everything is still
And there's no calculations in the report.
no calculation.
So that's what he's saying.
Okay.
In the brief, it says no calculations.
So just this discussion of
It's just
the
discussion and interpret the result of no calculation or equations or nothing. So is that,
Are you sure?
I thought that's what I read. Have you read that? I'll have a look. I'll bring it up.
I think it's too good to be true, Craig. Like,
Okay, for have you gone through this part? I will record the video for this too. For review. For the this is the bond probabilities. The bond, have you attend already
yeah.
the practical? Okay. So
But
I
that
will
is the tensile test.
no this is the bond range test. Remember when we show you the bond range?
Uh-huh.
Yeah. So you need to do some calculations. This is also one of the calculations you need to do.
Ah, the French, the one that he made.
Just made these axes so he's hit on the.
What is the practical?
Yeah, because on the requirements here it says the submitted report should not contain calculations, but rather outline your findings using tables and figures.
I mean, I can take care of myself.
Wow, that's
We'll have a
good.
look.
So I don't know.
Have you joined all of you joined the group
Yeah.
Yeah.
for the practical?
Masonry, yeah.
Let's have a look, Chris.
It says down at the bottom, in addition to your typed report, you will be required to submit handwritten
In the
calculations.
requirements.
That's
So
annoying.
yeah, it's called.
Yeah, but handwritten ones. That's annoying. Not in the report.
What are you expecting of it?
Excel.
Down the bottom of
You
it.
see, this one will take you forever to this
But
one.
down the bottom in the requirements bit, it says
So using the standard, you need to find what building the capacity of the wall compared to the experimental data. So you need to, for each wall, you need to calculate.
Excel.
I think Excel.
Oh, Mr. Lead is here.
Mr. Lee.
Mr. Lead is here. Hello, Lead.
Mr. Lee will ask about the assessment. I will tell him you have to.
No, you got it in the video.
You have to,
Yes. Just watch the video.
you have to contact Mr. Arkut to get. Why did I attend at 2? Sorry.
Other way.
At work? I was also at work.
Technically,
Yeah. Okay, so we have some calculation, guys. Don't listen to Craig.
No, you scroll down. It says
I know. The problem is somewhere mentioned no calculation. Somewhere here we have to calculate.
So we do all the capacities for every wall.
Yeah, you have this wall to calculate the capacity.
Bending, but just bending and axle, that's it.
Are you agree?
There's no axle, it's just out of plane.
That's good, chill.
Raise it up.
Yeah, it started raining off.
So just one, come on, it's not that
I was in the
bad.
office,
That's it, you can do it.
down at Adams.
Okay, so you can, if you use the spreadsheet, guys, you need to do what? You know the rule for spreadsheet. You need at least to show one of the calculation in details. One.
So
Okay.
you
Don't
can-
put it in Copilot.
full plan gone.
Put it
Full
in.
plan gone.
Put Excel in Copilot and generate
Yeah.
everything.
Eliminate everything.
Yeah, don't do that.
Try it out.
So one handwritten, one detailed one, and can we do the rest in the spreadsheet then?
You have the spreadsheet?
No, but I'm saying, can we make one and then just be
Yeah,
quicker.
because each wall, the problem each wall has different.
Someone, yeah, thinking so.
So, like for example, the single leaf, each one has different calculations. So this is the problem. But the good thing is you can. All of you have the same wall, so you can work together. This is the good thing.
Okay, what do you want to do? Reinforced.
Okay, so you need to
You've done it.
calculate the capacity using the theoretical calculation and compare to the value you get on the
You're in the good position.
Okay.
I
Michael,
started
do
the
you have
first
any
one.
question about the
I
practical?
divided the second part in her and
You think of nothing
Have
yet?
you done the pro?
So you expect something like this for each one. So at least for each one you need to do what? Load.
can't think.
You need to draw the load displacement curve. Okay? This load is what? Which load is this? This is the point load in the middle. So this you can convert this to a moment. You know how to convert this to a moment?
Oh, the mid height.
Yeah. So it is BL over 4. Right?
Yes.
So actually guys, this was our wall.
You already done the
Ahmed, I got you the new thing.
Right? Do you remember how much was the height of the wall?
18.
18? 1800. So 900 and 900. Because you need to calculate what for the walls, the out of plane building.
Yeah.
So for the out of plane building capacity, you remember you need what? The moment on the wall or the moment applied to the wall. So this is the load V.
Yeah.
So what is the moment?
The reaction.
V L over 4. Okay? Is that correct?
Yeah.
I don't know what you're
Let's just shoot for the bedding.
This for KG2 structural engineering. BL over 4. So WL square over 8, BL over 4. This is the two things you need to at least know before graduating. If you don't know these two before graduating, so you need to go back again.
Don't need that to put pipes in the ground.
No, we don't need that. Just quite accurate.
Just dig the wall.
Okay? So you need to check calculate the capacity of the moment of each wall and compare to the test that. Another example quickly before we have a quick break. For example, if we look to the which one?
You know, the battery is done.
The last one. Remember what was the last one is?
I don't know how much left.
What was the last one? The reinforced one. So the reinforced
You
one.
think it lasts for 2 hours? Oh, this thing is cold.
What is the maximum load for?
Steel.
What is the maximum load for this one? If you look about
About 40, 45.
Okay. So again,
There's not much left, but it will be plenty.
How much?
12%.
if you look here, we have two lasers. The first one has only two lasers. So because they both, remember, they both two lasers at the back, one west, one east. And in some cases they put one at the other side.
When you write.
Okay.
And what
So
you see
here
is
they
you
give
can
you
screen.
laser 1 east, laser 2 middle, laser 3 west. Okay.
Remember.
So you don't need to use the 3. You can use the second, the east and the west. Okay.
Sorry, can you average it?
Yeah, that's what I will do.
Okay.
So actually, what we need is to get the average of these two, the east and the west. Okay. So the average these two.
Yeah.
Then we can plot the relation.
This is mine.
Okay. So this again is a relation between two. The load should be on the vertical axis, and the displacement should be on what? Horizontal axis. But as you can see, the measurement of the LBCs are negative. So what you need to do to make it easier for you, positive. So all the deformation you should multiply by -1 to make it positive. Okay? So I will do it as so this is the final value we need.
So it's still the full bracket. Just show the big.
Okay, so this is the load displacement for this wall. What you need to do at the end, you need to copy the final one here, put it in a different sheet to compare all of them together. So just for example, okay, after you finalize the 6 walls, you need to draw a graph to add them all in the same graph. Do you know how to add more graphs at the same block?
Yes, you go to
Plus?
select.
Which one?
Oh,
Select the data,
oh, I think.
add. Then you can add the name, for example, wall 6 or whatever. Then here, select this data. Here, select this data. Okay, you see the difference between the two? So the top one is the unenforced, the enforced one. The bottom one is the clay one. See how much is the difference? Yeah. So the first one is around 46, 48. This is the last one, the enforced, grouted, enforced, and concrete. The first one or the blue one is what? Is the clay one. So it will be interesting to put all the 6 together to show the difference in the behavior.
So you reckon all 6, or could we just keep all clay together and all hollow block?
Whatever, but it's better to put all of them together. You can
Okay. Yeah. Well,
compare each two. Like for example, you have 3 same, grouted, ungrouted, and reinforced. So you can put them together.
yeah.
But also, like a general comparison will be also good. Because all of them has same height, same boundary condition, and same setup, right? So you can still compare them. Like for example, in the research, you can compare even if it's too weak, but this show also advantage of the strong one. Okay. I know the graph looks weird, but it's okay. Okay, because this one is only 2 kilonewton, the other one is 45, so it is 40 times bigger than the first one. Okay, Matthew?
Yeah.
William is okay? Have his lunch? No beating today? No losses? No wins? Okay, can I have a rest for 5 minutes?
Yeah.
Still recording?
Yeah, press.
Give me the